Okay, so welcome back. Now, one of the things that you also want to notice or realize, and that I'm going to tell you, is that when you're dealing with an interval, over that interval you may have both an extreme minimum or an extreme maximum, or you might have one or the other, or you might have neither. Okay, but this next theorem gives us certain conditions where it will guarantee that there is an extreme, an absolute maximum, absolute minimum within a given interval. Okay, so let me explain. Let me read it and then we'll make some notes of some things. Okay, so in this theorem, theorem 1, which is the extreme value theorem, that's what we're going to go by. It says if f is a continuous function over the closed bounded interval a comma b. Okay, so there's the conditions, right? That's what we need to assume or should be able to assume or know. Okay, or given. Okay, so again, the function has to be continuous, and we have to be talking about a closed bounded interval. Okay, then there exists a point in the closed interval a to b at which f has an absolute maximum over a comma b, and there is also a point in the closed interval ab at which f has an absolute minimum over the closed interval a to b. So, now the proof of this is beyond the scope of this class. Usually this is proved when you take a class in real analysis, which is either your, real analysis can be either taken as an undergraduate or graduate level. Okay, so anyway, a couple of things to note though. The first thing is it has to be a continuous function for this theorem to apply. It also has to be over a bounded closed interval for this theorem to apply. If you have a discontinuity anywhere in the interval, then this theorem may not work, right? It may not be true. It's not guaranteed. So remember, this is a conditional. So if the if part is true, then the then part must be true. Okay? If the if part is not necessarily true, then guess what? All bets are off on the rest of it. That's how a conditional works. Okay? In logic, right? So this is all based on logic. So if we're dealing with a continuous function and we're dealing with over a bounded closed interval, then this has to be true. There must be a point in the interval where there is an absolute maximum, and there must be a point in the interval where there's an absolute minimum. And those might happen at the endpoints, hence the closed interval, right? Okay? So, just be aware if there are any discontinuities in the interval, this does not apply. Okay? Or if you're dealing with an interval that is either open or not bounded, then again, the extreme value theorem does not apply. Okay? Okay? Have a great day.